Binary basics. The easiest path to understanding zeros and ones. How base 10 works. Whether you realize it or not, you're already an expert in the base 10 numbering system, also known as the decimal system. You've been using it your whole life. It's the system we all use when we count, when we do math, and even when we tell time or check the price of various products. The term base 10 simply means that there are 10 digits to work with. 0 through 9. After 9, something interesting happens. Instead of inventing a new digit for the number 10, we reset to 0 and carry over to a new column. That carryover is the foundation of place value. Let's take a closer look at what's actually happening when we write numbers like 8, 80, or 800. In base 10, every digit has a place, and each place has a value that increases by powers of 10 as you move from right to left. The number on the far right is in the ones place. The next digit to the left is the tens place, then the hundreds, then the thousands, and so on. Each place is worth 10 times more than the one before it. This place value system is what allows us to use the same digits over and over again to create new numbers, simply by changing their position. With base 10, after we exceed 9 in the ones place, we need to start a new column to the left. That new column is worth 10 times more than the one before it. In other words, 10 ones equals 110. This same pattern continues for each new place value. 10 tens becomes 100. 10 hundreds becomes 1,000. The pattern keeps going, and it's this consistent structure that makes the decimal system both powerful and easy to understand once you see how place value works. Next, we have counting. Counting in base 10 is something we do so automatically that we rarely stop to think about how it works. You start with 0, then move up to 1, 2, 3, and so on. When you get to 9, you've used up all 10 digits. So what do we do next? We roll over to a new column, setting the current digit back to 0 and adding 1 to the place value on the left. That is why 10 is written as 1 followed by a 0. It is 110 and 0 ones. This rollover happens every time we max out a place value. Just as the decimal number 9 is followed by 10, the decimal number 99 is followed by 100. Each time we add a new digit to the left because we have run out of combinations in the current columns. This is what allows us to keep counting forever, using just the digits 0 through 9. It's kind of like an odometer in a car. When it hits the highest possible value in its current digit slots, it resets and adds a new place. This idea of rolling over to a new column once we run out of digits is key to understanding any number system. And when we switch to binary later in the course, we'll use this exact same principle. The only difference is that binary has just 2 digits, 0 and 1. So we will roll over much faster. But the structure of place value and how we build new numbers will stay the same. So when you think about base 10, think about patterns, place value, and position. The value of each digit depends entirely on where it is. That's what makes this system powerful and predictable. And now that you've taken a closer look at counting and have seen how base 10 handles place value, we are ready to break it down even further. In the next few lessons, we'll look at the different ways we can express these numbers, using standard form, expanded form, and exponential form. But for now, just remember, you already know base 10. It is the numbering system you have been using since the day you learned to count. Thank you for watching. Subscribe for more great content.